Thank you, sir. I hope I'm audible to everyone. So, thank you for the introduction. So, once the faculty from the college approached me regarding the software development, the solar. So, one software come up in the mind is the PVsyst. That's what we are going to learn today. PVsyst is a paid software, but I would request and the faculties who have joined, you can search it PVsyst, download on Google, and you can get it the trial version, 1 month free version you can access all the time. PVsyst 8 version is right now available. So in brief, what is PVsyst? PVsyst give you the idea about how to design or develop a solar plant, and it will also provide you based on the location. It will also provide you how much you can gain it from that particular plant, means how much energy you can extract from that plant. In the trial version, you might not get the correct data of prediction because the data is older one. I'll let you know when we are opening the trial version. You'll see that the trial version data stands for 1990. So solar radiation variations captured used for the simulation is from the 1990. In 2024, if you want, you need to purchase the PVSet software. So I'll go to the software directly. I'll share my screen. Please tell me if it is a visible one. Is my screen is visible? Okay. So I'll keep it like this way. I hope it is visible. Now, when you open the PVsyst, you will find these three options with you. One is a grid connected, one is a standalone system, and the third one is a pumping system. So today we are going to see regarding the standalone system, and in the tomorrow's lecture we will see the grid connected and pumping system. Means there are few factors if we cover it today, so it will be easier to tell you regarding the grid connected system. So right now we can just you can download this particular software PVsyst 8.02 online. You can get it. This is also a trial version, so you can get it online for 1 month free. That is not an issue. Okay. So let's understand what is a standalone system means. A standalone system means I have solar panels with me. I have connected them to a particular manner like series or parallel, and I am supplying it to the load. So like I am holding my solar panels at I'm keeping my solar panels at the top of my building, and I'm utilizing directly. So that is a standalone system. Grid connected means we are using the solar energy and we are dumping the energy into the grid. So standalone, we can correlate directly that I am using it for myself only, like that one. Okay. Just I'll give you the idea about this one. These are the databases or tools available here. If you need some tutorials or video tutorials, PVsyst provide those also. The options are available here. I hope the mouse is visible. And if you click it on that one, you'll get the PDFs and you'll get some information how to simulate the data based on that. So let's go into that one. So I'm just clicking on the standalone system. Now, once you click that, it will open this one. So what is the parameters here? First, we need to decide the project name. So I'll give the project name anything. So I'll just give my name to that one. So that is the name of the project. Okay. Then here we need to decide which site, geographical site we need to enter. Now somehow I could enter the Pune data in this one. If you see that there are a lot of countries or a lot of locations are mentioned. In India you will find only the Pune data is there. Okay, somehow I could enter in the trial version. If you purchase the uh, entire version for the PVsyst, you will get whatever the name you will put it, the city name, it will fetch the data from that. Now this is the important one because once I am getting the Pune data, the data means the radiations, the ambient temperature, the wind variations here, all the data will be captured from particular location. So if we are getting the particular location data, it would be the good one. If it is not, then it's a problematic thing for us. So somehow you can see that all the data are from the 8.2 version, but only one data is from 7.1 because I have imported this data from the previous version of the PVsyst. So this is the data available with me. That's what I am just selecting my data, the Pune location. So first job is to select the Pune location. The next again, this is the .met file, meteorological file, which is available with me. So if I click it on this particular weather database, so it will show me regarding the database available right now. So I'll just showing you up what is here. So this is nothing but telling you about the Pune location and all. And this is the important one. What are the data available with this one? So in this data set, we have the global horizontal irradiation and diffuse irradiation. Irradiation means the solar light or solar energy, which is measured in terms of the watt per meter square and hourly. So if you want to see the graphs also, so this is the graph, this is the data which already there. Now you can see the date here. The date here, I'll highlight it if possible. No, it's not one. Right, this one. You can see on the x-axis there is a date of 1st January 1990. So due to the trial version, I could not get the recent data. But if you purchase one, you can fetch the recent data also. So if I go to the next day, so what is the date on the, what is the irradiation data for the 2nd January, then 3rd January? You can check all this data here. So I'll close this one. So this is the data points what we are going to import. Importantly, again, these are the coordinates, like say 18.53. Okay, I hope my mouse is visible, mouse arrow. Can somebody just so this is the latitude and longitude, altitude, and time zone data, which is already there as I have imported the data. So it is showing me exact points with this one. So I'll just close this one. And these are the other data points if you want to, generate or you can do that. Now, right now we are not interested in those parameters. We will just go into the project one. So this particular section, the blue one, it will give you what you need to do the next. It will just like a steps one. See, PVsyst is a software designed, user-friendly software is there. So once you are familiar with the PVsyst, you can do many things inside that one. So just to guide the users how to design a particular plant, so they have used some methodologies for that one. So here they are asking, please save the project. So I need to just click on the save, and once I save the project, now they will guide me that please choose the orientation, plane orientation. So now we will go to the orientation. You can see the tabs over here. The orientation, user needs, system, detail lost, horizon, near shading. So we will see, go to the each tab one by one, and we will see what we are interested into that. So orientation, it it is actually asking you how you are setting up your panel for the Pune location, how exactly you are setting up your panel. Now, once we are saying that solar panel, there are different orientations are possible. So right now we are seeing at the orientation which is fixed tilted plane. This is the options are here. The fixed tilted plane means I am setting up my panel a little bit tilted with some support, with some structure. And right now the tilt angle I am keeping it as 20 degree. Now the question is, yeah, there is another angle. It's called azimuth angle. Right now it is 0 degree means it is exactly facing south. This particular one, it is azimuth 0 degree. It is showing that it is exactly facing the south. And tilt angle means you can see the blue line. The same way I am keeping my solar panel with the 20 degree angle. You can see the angle between the black line and blue line. This is the important one. Now, how to select the exact tilt angle? So what is the thumb rule? The thumb rule says that whatever your latitude, you can keep your tilt angle that as it is. The some thumb rule says that latitude plus 10, latitude minus 10, you can keep it the tilt angle as it is. Now here we have some opportunity to check it, how we can select the tilt angle. Now here you can see that it is this particular 20-degree angle, it is for the winter, October to March. There is another option, summer, April to September, and there is annual yield. Annual yield means it is telling you about the entire year. So if I am fixing my panel once, that's it, that is the final fixation. So for that one, I will select the annual yield. Now, how to check that is it good or bad? See, a small change in the tilt angle doesn't make huge differences. In the good range, if I'm keeping my angle as 23 to 18th or the 17th, it doesn't matter actually. It does not give you the huge differences, significant differences in the production of the energy. But let's see that. Now here on the graph below, you can see that there is one word is called F transpose, and it is showing 1.07. So F transpose, we want this number should be very high. So what is F transpose? I'll show you in the numbers. If I change this tilt angle to the 0, the F transpose goes to the 1. So F transpose is nothing but what is the solar radiation coming on the tilted plane divided by what is the solar radiation coming on the horizontal plane. So this angle F transpose should be greater than 1. We wanted good value. Or there is another one, we can see that loss or optimization. So right now 8.6% loss we will observe if I am keeping my solar panel flat on the ground for the Pune location. Okay, so I'll select my angle. I'll just show you that how the this changes. So I'm selecting my angle as 18 first, 18 point something like that. Now you can see that the loss is 0.3%, 0.03%, and the F transpose is showing 1.07. Now even if I'm changing my angle little bit here and there, the loss is reduction is there by fraction, but F transpose values remain the same. Means these angles are as per your requirement. The exact angle is 23.2. If you see that the loss is 0 and the F transpose values remain the same as 1.07. Means this is the good angle. As I mentioned, you can vary your angle in between the loss. Now see again, this is the annual yield. Means this angle is fixed for the year. So if I have the opportunity that okay, I can select the two angles. So between the summer times at April to September, I'll select different one during the winter time. That is also possible for me. So we'll go to that one just to understand this F transpose or loss parameter. So here I'll select the angle as 23 just to make sure it's fixed over there, or I can directly type it here, the 23 angle. Okay. Now, what is the azimuth angle? Azimuth angle, as I mentioned, right now the panel, you can see this red dot, the panel is exactly facing the south. That is ideal direction we want. So let's change it and let's observe that what will happen if I change the azimuth angle. Now you can see the plane orientation here. Now, if I click on this red dot and if I start rotating my panel, you can see that the blue dot is shifting. The blue dot is nothing but telling you that how much yield you are getting it or how much energy you are getting it. So even if I'm changing my angle like this way or like this way, you'll see that the blue dot is shifting to one side, or you can see that the drop in the F transpose or loss parameter increases. So ideally, we should face our panels exactly to the south. The reason for that, we know that the sun rises at east and goes down at west, but we are in the northern hemisphere. So one thing we should understand that the sun, even if it is east to west, but it travels always facing to the south direction, because that's what the reasons normally people say that to keep the protection whenever some constructions are there going to there. So people said that please keep the protection at the south. The reason is the south side of the house or south side is always in the focus of the sun. So we need a lot of protection over there. Similarly, for the solar panel installation, whenever you are seeing any installation, you can see that all the panels are facing south to get the maximum of solar panel. So this is one of the orientation. Now let's change the orientation. Now I have the opportunity that or somehow I cannot face my panels keeping the south direction. Due to any reasons, there is a tree or buildings are there. So there is another options. It's called domes. The domes means you can see that blue line again. The two panels are kept it like the slanted way or like east west facing like this way. The blue lines are suggesting the panels. So these are the domes. Dome structure is there. Means whatever the angle you want it, you can select it. Whatever the orientation thing. Then there is a seasonal tilt adjustment. As I mentioned, summer and winter, we can have the two adjustments for that. So they are giving you the directly selected one that for first 3 months, the adjustment is like this way, winter and summer, the 20-degree and 50-degree for the summer. So you can select the month whenever you want it. You can change this direction also. Now here you won't get the direct one. Once you simulate, you will get the idea what is the answer. Otherwise, we have to fix with the default values. These values suggested by the PVsyst only. Okay. Now there is another one. There is a shades like structure, means we can keep it the panels like this way, such that the first panel shading should not be there on the second panel. So we have the ground ratio and all this one. So they are saying that shading limit angle is 21.5. So we should make sure that this angle is there. Even you can change the tilt angle. We can change the pitch and all this stuff. Again, these are the parameters we need to check whenever we are our orientation changes. Okay. Now there is another one is the tracking one, the single axis and dual axis. I'm just going through the different orientation just to give you the idea that how the orientations can change the details. So this is the tracking angle again. So tracking means we are following the sun. So there is no need to check the angle, which angle we are keeping it and all. So entire day we are just rotating our panels as the sun is moving. So this is the single axis tracking, and similarly there is a two axis tracking. Two axis means there are again azimuth angle will also change and panel tilt angle will also change. So these are the various options we can select in the orientation. Once we know that okay, we need to set up the solar plant. Now, depending on the area you have, we need to select the particular orientation. If you don't have the bigger area available, so you can go for the dome structure. You can also go for the tracking one, but you need a lot of support over there for the smaller areas. The tracking, you need to be very careful about the support system. You can give elevated support such a way that some pillars over there and you can install the tracking system. If you ask the solar manufacturers, the mostly manufacturers won't suggest the tracking system. The only reason is that the maintenance. Once we are installing the solar plant, the only maintenance is the cleaning of the solar panel. But once you add the tracking system, so it will again add some maintenance part in that one, so motor maintenance, the actuator maintenance, and all. Second thing, what is the known value that how much we are getting using the tracking? So as per the published data, we can get the maximum of 39% extra from the tracking system. So if your plant is very huge or megawatt or more than that, so we can think about some panels with the tracking one. But if you are going for the 3 kilowatt plant and with the tracking, now you need to be very careful that if I am hitting the maximum value also, that 39% maximum, so how much energy I am getting it and how much the cost I am paying it. So we need to be very careful about selecting those things. Normally nowadays, which orientation people are suggesting is the seasonal tilt. Seasonal means you can go for the two adjustments, two angles for the seasons. That is giving you a little bit more compared to the fixed angle. And the best one, or what you can say, without any reason, if you want to go for the particular one, it's a fixed angle is good one. Again, for winter, it is not producing the good results. For the summer, it is giving you the good for annual one. So you need to select some angle here. As we set it to 23, right? Okay, I'll type it again. So this is the angle we are selecting for our this simulation. You can try out, you can check, you can compare the results of the different simulations with the fixed angle, with the rotations and all. That is the idea, or that is the basic application of this particular software. So I'm just clicking on OK. So once you click OK, it will show with the green light. So we are done with that one. This star mark means we have changed something. So right now I have changed the angle. Instead of 20, I have kept it on 23. So that is the change it is asking. So the star mark means change. The green one means you are good to go. Now, it is saying that user needs are not defined. With standalone system, you have to define valid non-zero user needs. So it is asking to fill up the next user need. Okay. Meanwhile, I'll just keep on asking if any doubts are there. So please keep me updated because I can't see the chat now. So is there any doubt, any explanation required? Okay. Okay. Thank you. Okay, so let's go to the user needs, or this is a standalone system. So as we know that we are fitting up the solar power plant at our home for our use. We are not sharing this with the MSCB right now. We are using it for our side only. So I'll click it on user needs. So first we need to define how many appliances are there in there we are using it for that. Means in other words, the load of our house. So I'll define some application because it's mentioned that. So I'll say that there are 6 LED bulbs are there. Okay, let's assume the wattage is 20, and let's say that I'm using it 6 hours per day. So I have one television set. Let's give the wattage as 150, and to be precise, we'll keep it at 3 hours, which is on the higher side, but still. And I will say that I have one refrigerator or fridge. I'll keep this wattage as 350, and this one particularly runs for 24 hours. Okay, now whatever the things you need to add here, so one domestic appliances I'll keep it there with 100 watt, and we'll keep it like, say, just to define that it works for 8 hours, or make it 4 hours, it will be better. Okay, so here we can define whatever your needs are there. See, PVsyst will tell you that how much plant you required, or it will tell you that if you have the plant of 3 kilowatt, how much it can sustain. So it is providing you both the answers. Right now, I am looking for one answer that I have the data with me. So I am specifying my load and tell me what is the plant required, or if I'm going for the 3 kilowatt plant, how much you can sustain, how much you can, how much I need to rely on the MSCB or similar like that on other sources. So here I just defined some load with me. It is calculating the daily energy based on watt hour, based on the requirement, but it is saying that specify the hours. Now this is also important because uh, if we have defined many things at once, so we need to specify that where we require the maximum energy. If we are saying that in the morning we require the energy, solar is there, it can provide directly. If we are saying we require the energy in the evening, so we need a battery system for that one. And depending on our energy requirement, the battery system we can vary. So here I can click it on hourly distribution. So as I mentioned, there are 4 appliances are there at my home. So one is LED lamps, TV, domestic appliances, and a fridge. So for the fridge, it is already mentioned it is working for 24 hours. Now for the LED lamps, I have mentioned it for 6 hours. So I'll make it here. Like, say, this is the hours knob. Now we can say that from 6 o'clock to 12 o'clock I need LED lamps. So I'm just clicking on the areas. You can see that this is the requirement for 6 hours. You can see that here it says OK. Now if you here somehow I missed it, or I have modified it 5 hours, it will automatically update this particular number. So this daily use is already depends on the hourly distribution. So if I'm saying 6 hours, so I'm making it. Otherwise, you can modify here also. So TV, I said it 3 hours, so I'll make it here, change it here. So 6 to 9. These are the 2 hours and 6 to 9. And domestic appliances, I said it 4 hours, so I'll deliberately give it on the other end. So I'll say in the morning. Okay. So this is the way we are giving what is the distribution of my load entire day. So once it is saying okay for all these things, then only you can click it okay. Again, the consumptions here we are defining it by year, seasons or months. So I am defining it by years, that every day in the year. Now it is asking that it is a weekdays or weekends. So it is 7 days or week, or use only during, like that also we can define. So I can say if I'm installing for my office and office is working for 5 days a week, I can change this number to 5. So depending on the number, it will change it. Otherwise, I will say that use for every day in a week. So if I'm going for my house appliances, I'm using it every day here and there. Okay, so like that. So other profiles like say fixed constant consumption monthly values, that also we can include. Right now I'm keeping it as it is. Okay, so user needs. I'll miss that one. I'll cancel that. Something happened to that one. I'm okay. So these are the things we can give it, that what is the daily profile or monthly values. Also, we can suggest that this much required for me. So right now we are giving the, or we can load it from the CSV file also. So I'm giving just some fixed profile constant over the year. Yeah, can go it here. And we can give the fixed profile also, that how many hourly value we can specify. This is the other profile, that we don't have something known to us. So we can say give it randomly also. In kilowatt, we can give some values like we required here, the 10, and we can specify here something like say 30 or something like that. So it will create the profile on the background. You can see that here we can give it the 50. So according to that one, it will create the profile, and it is hourly basis. So we can give that particular one also. Okay. And we can say that randomization also we can make it, but let's say we are giving some values right now. So we'll fix to that one only. Somehow I cannot go back to the previous one. So right now I'm clicking OK only. Let's define based on that one only. Okay. And now you can see there is a green for the user needs also, and it is saying please define the system. So user needs, we have defined it from the daily profiles. Some value I have defined it, nothing else. So household use, we can go back, and yes, we can go back and we can give the values also in the household use. So that we have seen that how to give this particular one. We'll give some random values right now just to check that how much we required it, or we can give the household use also as we defined it earlier. Okay, so we'll give. I think we should go for this one. Just quickly put some values here so that we can. Here I'm just giving now fridge, which will work 24 hours a day. Power I can give 350. And as we know, we need to specify the regions where we are using it. To remove this one, you need to do the right click or left click based on that one. And for the fridge, it is used for entire one. So I need to go entirely. Yeah, it is taking too much time for that one, but always better to go with this. And it is for the month of January, let's say that, and click it on OK. And I'm clicking OK. So it is taking that load as a input. Now let's define the system. The user needs you can modify whatever you want it again. Now this is the particular system defined one. Now you can see here there are some window. You can see here the list of sub arrays. This is the number of module, the module area, and all the stuff. Right now we haven't defined anything. Okay. Here they are saying that available daily needs. It's let's say 5% loss we can assuming here. And as per the data provided, 29.3 kilowatt hour per day. It is the required one, and we are requesting autonomy of 4 days. What is meaning of autonomy? Autonomy means the 4 days, if there is no sun, like say cloudy environment is there, still our system will run. So normally, what is the autonomy people are keeping is 3 days, but we can change it according to. We can keep it as a 7 days also, depending on the region. If we are sure that 7 days there won't be any sun, we can't see the sun in the rainy season, then we can go for that one also. So these are the autonomy, and the load profile holds the data only for the 1 month, as we are providing for the January only. And this is not okay. It's a pre-sizing and all, so we'll provide the data for the entire month. Okay, so I'll go to the cancel. I'll define the user needs again. Okay, I'll do one thing. I'll go to the new project. It would be the better one, because it is not allowing me to go back because it's the data is saved one in that one. So I don't want to save anything in here. I'll again go to the project one. The data is been there already, Pune data. So orientation, I'm keeping orientation as 23. Quickly I'll go to that one. User needs, now this is for the entire year, the user daily needs. So I'll keep it again, we'll keep it small. And let's specify some hours again. Here we are okay. And we are here for the system one. Okay, now again this is the 5% loss we are assuming. The battery voltage, it is defined right now to 240. We can change it afterwards, we will see that. And the day need is the 352 kilowatt hour per day, and requested autonomy is 4 days based on that one. So we can change this autonomy, let's say we'll change it to the 5 days, or we'll keep it like this. Okay. Now, what is the suggested capacity of the battery? It is saying that 8,618. So it's too big. And suggested PV power is 88 kilowatt peak. Now see, it is saying that if you have the 88 kilowatt plant, then you don't need any other supply entire year with the 5 days autonomy. If I have reduced this autonomy days to the 1 day, let's see what is the change it is making. Now, once I change the autonomy day to 1 day, you can see the drop in the battery sizing and the rise in the PV sizing, because we are not using the heavier battery right now. Okay, so autonomy, as we are saying that it is depends on how much we are setting up, and based on that one. Now this particular array or this particular calculation gives you that, okay, if you set the 92.3 kilowatt plant, it is entirely means the plant will take care of each and everything, even there are 3 days no sun is there. Okay, that is the saying. We'll see one by one how to go for the sub array and all. Okay, the first thing is the storage. So storage, we have the numbers, let's say uh, battery makers. So we need to select one known, let's say Panasonic or something. No, it is not there. Again, this data might change. Okay, we'll go for the Sony batteries. This particular data set, it is already there in the PVsyst. So if you want to set up or add some new data set, it is possible. We can add some new data set in the full version. In the trial version, we have to go with the particular data set. Now Sony having only two batteries in the list, so it's better to go for something good. I can't see the Excite here because it should be there. Yeah, it is there. Excite classic one. And here we can select some batteries whatever required one here. Again, it's classic means it's not giving me the much more options. Why is also there? Yeah, okay, it's see here what I am doing, I am selecting the battery based on the voltage requirement. Okay, or we can select it based on the capacity, or we can select based on the manufacturer also. Okay, so based on the voltage requirement, I am just selecting some battery. Let's say we'll see select the battery of 48 volt 200 ampere hour, like that one. And my battery voltage is 240, so based on that it will tell you how much batteries you need it, and how much in series, how much in parallel. It is calculating based on my requirement, or based on whatever I have filled the data. Okay, so if I change this to the another battery of, say, you can see that there is only one in series, six in parallel, and 691 is the battery requirement. So based on that one, it is calculating entire thing. So right now, just to be on the good side, we can select it 48 volt 200 batteries. Don't see the battery numbers right now because that will change as per the requirement. Okay, this is PVsyst calculating. We'll see how we are calculating also. Means we are giving the number, and how we are getting the values, that we'll see. Now here after storage there is a sub array design. Now here the plant power is showing that 92.3. You can see it here. The plant power, it is showing 92.3. Now here we can change the value. Now we can keep it the plant power as it is, showing that we required to supply that much load, we required this much PV power. We can change this value. Let's make it to 10 kilowatt. Now I am telling that I don't have this much area, or I don't have anything with this much. I am keeping this particular value as 10 kilowatt. So what will happen now? No sizing, meaning I don't want to do any sizing. You just give me as per my load. Plant power means I am telling that, okay, this is as per the resizing I need for this particular. I have only this much panel available or plant available. Now, based on that, give me the idea. So let's see that. First, we will select the panel also here. So based on this one, 10 kilowatt plant, we will select some Vari panel. Vari energy is available here. So we'll select one panel. It is showing that 554 watt peak. Watt peak means maximum. One panel is there, silicon monocrystalline. This is the panel number is there, and it is available since 2024. So this is the data available with this one. Another data is required over here is maximum voltage is 36 volt, and VOC, that is open circuit voltage, at minus 10 degree it's 54.8 volt. Now these are the numbers. Now depending on your requirement 10 kilowatt, it is also telling you that you required 18 panel for to satisfy the, or to plant the power, depending on the requirement. If I goes for the no sizing, let's see it is changing or not. It is showing that, okay, no sizing means it is not showing anything. based on it is giving you the idea. Here it is saying that approximate needed panels are 18. Okay, and after the panels we need a controller for that one. So I am selecting first, let's say DC to DC, sorry, MPPT converter. So this is the maximum power point tracking, and based on my requirement, I will select some. Now here we have some options. See, universal controller means whatever the maximum is there, you can select on that one. If I uncheck this one, it will give us the opportunity to change this one particular one. So right now I need to select some company here again. Generic value, I'll select some known company that is not there, anyone. Okay, see, we required the MPPT converters for 10 kilowatt one direct coupling. So based on that, I need to select one maximum. This is available 54 watt. Okay, again, I am selecting this based on the available data. Okay, sorry. I'm selecting this between the available data. Again, you can actually in the full version, you can add some data, whatever the data available with you, and based on that also you can calculate. So I'm just calculating based on the available data. Now, number of controllers required, because this is 54, we are asking for 10 kilowatt. So number of controller required are 2. Now here you need to check two things. First thing, the VMPP at 60 degree, it's 108. Is it okay? So it is in the range of 48 to 200. It's good. The VOC at minus 10 degrees 164. Again, it is in the range. So it is good one. And VMP at 20 degrees again in the range. If this range mismatches, then yeah, this will produce error in this particular box that something is not matching like that. So if we select something, okay, we'll see that afterwards. Now it is saying that the designed array, we have the 3 in series, 8 in the parallel. You can select the numbers as it is selecting the numbers. What is the number of modules required is 24, area is 62 meter square based on the models we have selected. So maximum operating power it's 12 kilowatt. It is showing that based on the selection one, and the array nominal power is 13.1. So depending on the required one, controller's efficiency and all efficiency taken into the picture, it is giving me these numbers. So I'm just clicking on OK. There are some backup. Okay, if you want some backup generators, we can set up here, and simplified sketch if you want it. So this is the sketch we are developing. So if the backup generator is there, I need to click it here and define it. Otherwise, these are the parameters we are defining it. This is a PV array, this is a regulator, this is a user need, and batteries also. So this is the systems we are designing here based on our requirements. So if I click it on OK, so it is showing that yellow sign. Yellow sign, what is saying that the PV array, or it is there or what? Okay. PV power is strongly undersized. PV power is strongly undersized, and means whatever the defined is 10 kilowatt, it is showing me for the 12 kilowatt. That's what. So that's what as per the needs. So here we are giving some random numbers right now. 10 kilowatt is my number. Even if I change this one, it will give you the numbers as per the requirement. Okay. So once we are dealing with the grid connected tomorrow, we will go for the with proper system numbers. Here standalone system, we have defined some random load. So for that one, I'm just defining some random numbers, nothing else. Okay. So after system, you can define. Let's see the detailed loss. Now this is the one parameter you can define it. You can give some values, or you can go with the default values. Okay. Now detailed loss. See, in solar there are different types of losses are there. There are thermal losses are there, ohmic losses, LID, that is the light induced degradations are there. Soiling loss means the dust deposition on the panel. Then there is a IMA loss. We'll go to that one, and spectral collection. So PVsyst consider all these different losses to calculate their final output. So thermal loss, you can see here the default value as per now. If I'm keeping my panels pre-mounted on air circulation, if I select this one, there are two factors: constant loss UC and wind loss UV. Now, if I select on this particular one, you can see that the UC value changes to 29. Uh, Other than this is normally the fixed one. If I keep the structure like dome structure, this value changes to the 27. So this particular factor changes as we select the orientation or as we are keeping the panels. So this is insulated integration on fully insulated back. So this loss is 15 ohm. Okay, and wind factor loss we can normally give some value here. The basic value is 3. Sometimes people will give 1 and 5 also, depending on what is the wind velocity is there. So I'm just defining some loss numbers here to get the answer, nothing else. Okay, the losses graph, you can see that if I'm keeping the panels at 25 degree, you will get this IV curve, and when I'm adding some losses, we can get the different IV curves for the different losses. Now let's go to the next loss, that is the ohmic loss. So here again, see, every time PVsyst will give you some default values, and it is suggested that you can go with those values, it will give you the nearby one. But if you have a huge plant with you, let's say 1 megawatt or something like that, so you should know the values, like say what is the wiring resistance, what you are going to calculate. Even you can calculate also, but here I'm going with the default value, that 1.5% loss. You can change this percentage ohmic loss, or you can give the details also, that detail computation. So what is the size of wiring, what is the diameter, and what is the length. Based on that one also you can calculate the ohmic loss. Right now I am going with the default value. Again, whenever I am going for the LID stands for the light induced degradation. So whenever you're keeping the solar panels in the light, so there are some degradation happens when the light strikes on the panels, a small one. So what is the efficiency loss yearly? You can say 0.5%. So again, I'm going for the default values, LID values also. I'm going for the default. It's a 2% one. So these are the different losses considered for the calculations in the PVsyst. So this is the 0.52. With the difference one. Module mismatch losses means some models can produce the exact one or efficient one as per the given data sheet. Some models are little bit here and there due to some cell heating up and all. They cannot produce what is the expected power. So there is a mismatch between the two modules, that is creating some problems. So that loss is considered as 1% LID, as I mentioned, and power loss at maximum power point is just we have observed some loss. Default value is 0.1. Okay. Now again, soiling loss 3%. Normally they can take it as a default value. Once I click it on the default, it will say that, or you can define the monthly also. See, normally in the rainy season we don't get much of soiling loss because all the dust particles are settled down due to the rain or due to the humid environment. Whereas in the summer season we can experiment, observe a lot of soiling loss. Now it depends on where you are setting up your panels. If you are going for the Rajasthan or any desert areas, then soiling loss is on a very higher end. Whereas if you are setting up your panels on the elevated structure at your home, where there not much of traffic around over there, then the soiling loss is very less or negligible. So again, as we are setting up this standalone system, we are going for the default value. Again, this is the incident angle loss. So incident angle loss means what? I'll show you the grid connected system in that one. See, whenever the light enters in the solar panel, there is a glass over there and silicon panels are there below the glass. Now, due to some incident angle, some light may get reflected back. Reflected back means it's reflect from the glass also, and due to some incident angle, some light may reflected back from the solar panel also. It won't get absorbed. So there is some loss due to that one. We are considering this based on this. So that's what we need, some anti-reflecting coating and all. So right now we are considering this one, and this is spectral loss. We are not. We can say that use spectral loss in the simulation. It will say that water column and all, but we can say that this is the different losses are there. We can say here we can define some user defined also, or means we can say that we know the coating, what type of coating is there. and we can say that for this incident angle what is the loss and all. But we are what you can say, we can use this definition as per the PV model. So what PV model we have selected, depending on that one it is selecting this loss. So this is the loss. We can click it on OK. So these are the detailed loss and system got defined here. Now, again, I need to go back. Is any doubt, queries, questions? I'm interested to answer. Losses. Okay. See, in the solar system there are different types of losses are there due to the thermal, due to the we can say that due to the wire resistance and all. Okay, so here we are defining the losses assuming that the shedding loss and all the coming upward, no, haven't considered any loss due to the shedding. Now, thermal loss means that how we are keeping our panel. Right now, our panel free mounted modules with the air circulations are there. Then there is a fixed loss that we can say that 29 watt per meter square Kelvin. This is the loss. Okay. If we are keeping the panels in the dome structure, if we are keeping with the integration with the back, so depends on that one, the losses of the solar will change. Okay. There is another one. If you want to see this, this is called NOCT. NOCT means nominal operating cell temperature. So if you click it on this one, it is saying that 45 degree. So if your panel cell are working at 45 degree, it's good one. If it is going above that, it is bad one for that one. So it is defined based on the panel again. So the losses happen at the solar end. If we consider for the simulation, you will observe that there are sometimes there is a huge loss, sometimes there is a won't be any much losses. But over the year, if we want to see, we cannot calculate for the every day or every month. So PVsyst allow us to consider these losses into the picture and giving you the output based on these losses. These are the losses related thing. So if you are asking regarding the particular losses just for the LID or something, so LID stands for the degradation loss. So degradation means the panel degrades every day by some means. So we have to consider that degradation loss. Or soiling loss means the dust deposition on the panel glass. So based on that one, 3% loss, we are considering that every day there is a dust deposition. Now, if you are cleaning the panel every 15 days, then this loss may you can reduce it. If you are not cleaning, then this loss goes on the higher side. So these are the losses considered while production of the solar energy PV panels, and consideration in the simulation will give you the exact picture how your plant will respond. Anything else? Okay. So I'll just going back again. Now, now here there is a two things. One is called horizon. Horizon means if you click it on this one, you will find there are numbers like say 1, 2, 3, 4, 5. But these numbers suggesting that see you can see some black lines here. I'll just go for the number one. It's saying 22 June. Now you can see here number one is on the corner of right corner. Okay. So horizon gives you what is the solar track or solar uh, trajectory for particular day or particular month. You can see. I can go by like say let's select one three number. Three number it stands for 20 April and 23rd August. So solar will go by this particular track by this follows this trajectory, and we are getting this. Now this horizon is used to calculate far side effect. Far side means you have kept your panels somewhere in the open space. There are some buildings away from the panel, but there is a possibility that these buildings can create a shadow on your panel, maybe in the month of December, maybe in the month of August. You don't know. Okay, so if you want to check this one, so you have this opportunity. This is the behind the plane, this is the behind the plane. Now if I, you can click it on this one. If I raise here one shadow like this way, so I know there is some object is there. The azimuth angle will tell you that azimuth means the rotational angle will tell you that at this particular angle, I know the height of the particular one. You can see the sun height related that one x-axis. So we can define. Okay, there is a one object. Now you can see that that object can create some problems at the end. At the end, in the sense you can see that 6 o'clock it can produce some, or 7 o'clock it can produce some shadow on your panels, or like that one. So this is also called as far side shading. So normally, uh, in the calculations, normally we keep it the panels in the open space because we don't want any shadow on that one. So that is the reason. But even if you want to calculate, see, in the morning 6 o'clock, if you having some shadows, it doesn't matter. In the evening after 6, you are getting some shadows, it's okay, because after 6 you don't have that much sunlight available, so that is also okay. But if you are getting the shadows in between time span, like say if I keep my one of the shadow like this way, then it's a problem for you. Okay, so those parameters we need to check or calculate. Right now I'm keeping horizon at a 0 1. You can add some numbers here, like say I can keep some far side objects like this way. Keep it down, it should not be like that. I can keep some objects like this way, but it is better to keep it 0, because it is our assumption that we do not have. Okay, now you can see here on the right side plane, it is saying that what is the height of the panel, and what is the height of the object, and what is the azimuth angle. So based on that one, I can give some points here. I can keep on adding some points like this way. So there are 9 objects around the panel with the given height, azimuth angles, and based on that, is it producing some effect on my panels? You can calculate that way. So normally, I would suggest you can keep it on the clear one. Clear one means we don't have any object in that one. This is for far side. For near side, we'll again see into the grid one how the near side shading will happen. Okay, so I'm just keeping it okay, horizon. Now this is the near shading. Now near shading means, is there any object near to your panel which can produce some problem for you. So here you can actually create some objects, like say this is the plane, and I can go to the create. I can say some building object, or I can go for that one. I'll go for the uh, let's say array trackers or single PV panel tables, like that. Okay, and we can say that this is the available, or this is the panels how we are keeping it, and we can add some here also. Okay, let's close this object, and I can create some building components, ground object. Let's see, ground of, no, don't go for the ground. We'll go for the some simple one, some elementary shading object, like that one. The box is there. Okay, and I can select it from this one. Is it the square or something like that, house or roof? Based on that one, it will change the directions based on that one. Okay, so I'll keep it like this way. I'll close the things. Now if I'm keeping this object like this way, now you can, I'll just telling you the idea. Okay, now if the object is like this one, it is hiding entire things, it's a problem for you. Okay, now, okay, it is saying that the area in the 3D part lower than the area of the module. So the sub array, we need to change this one, obviously. I'll delete this particular one. I'll go with this one only. Okay, we'll see that adding of some. Hmm, yeah, it's not available. I'll see that in the grid connected system, we'll add one of the wind turbine nearby. So just to check that what is the object and all that. So, okay. Now, right now the linear shading, if I'm keeping that object only, it is showing that it's a linear shading. I will select this one as a no shading. No shading means there are no object nearby available. So I'm just keeping that as it is right now. And once we are done with the orientation, user needs, systems, detail loss, we actually do not need to go into the horizon or near shading if we don't have anything. So we can directly run the simulation based on this. So I'll just clicking on the run simulation. You can see that. Okay. Now here our analysis part starts, because we need to analyze is our panel is okay or not. So first thing, the main results, what is system production is 29.9 megawatt per year. The specified product is given is 1826 kilowatt per year and all this stuff. Normalized production is the 5 kilowatt. Array's losses is given. System losses are given mentioned on that. Now nominal power, as we have selected some panels and all, is 13.1 kilowatt, and total battery voltage and battery capacity, based on that the numbers are given. Now what exactly report we want it, we can generate it from that one. So here there is a option that predefined graphs. The predefined graphs will tell you the different uh, values for your particular array. So let's take one of the graph. It's saying that array temperature versus effective irradiation. Okay, so if I uh, put a graph or this one, you can see there is some linear line regression we can perform, and we can draw some line. So predefined graphs will tell you, let's say, what is the system loss. So system loss will tell you that these are the part of the loss we have considered in this particular simulation. This going out array means these are the losses from the system. Okay, so these graphs normally required to analyze the system in the detailed way. Now what are the graphs available with us? Let's analyze that one. So daily input and output diagram, you can see that it is showing that what is the useful energy we are getting it, and daily means 1 dot per day. Okay, here it is showing that performance ratio. So what is the performance ratio? And solar fraction means how much we are sharing our load based on that. So you can change this one. Okay, these graphs you can change it here, from here also, the detailed graphs whatever we required. We can see that what is the productions, what is the unused energy or batteries full. Based on that one we can change these graphs. So this particular analysis will tell you that how our panel will react, or how our plant will react over the year from January to December. How my production and losses factors are there, is it okay to supply my needs or not. So as we have selected very huge plant for a very small load, so it is okay. We have selected 1 day or 3 day autonomy. Based on that the battery capacity is okay, and it is supplying the entire load as per the requirement. Okay, here you can say our power distribution of the array. So how the powers got distributed, effective output per kilowatt. And this one will tell you regarding the losses, again array temperature and effective losses. Regarding that one, this particular one tell you that. Now if I want to get the numbers, because I'm interested in the numbers values, what is my number, so I can get it the numbers from here. So what is the we can give some random numbers here. So balance and main results will go for the weather data. Okay, so what is the irradiation and energy data, we can get it for January to December. Again these numbers for the 1990 data, as this is the trial version. And you can see that what is the global horizontal radiation, what is the diffuse radiation, ambient temperature, wind velocity and all from this one. So as a faculty, if I am going for the publication, so I need these numbers. It is important. Once I select one of the parameters, you can see it here. What are the 6 parameters are there? Effective energy of output, load, then user energy supplied per user, then there is a solar fraction and all this stuff. So if I got this particular table, so what is each parameters of this table tells you in the previous panel, and it gives you the idea what is the requirement, what is this, what is the T. It's a duration of loss of load. LOL stands for loss of load. So as our system is perfect one, we are designed the system with the huge numbers, 13 kilowatt with the small load. There is a loss of load, hours are 0. Loss of load means there is a one parameter or one section where solar cannot provide, or even battery cannot provide the load to your system. Now see, in this calculations, entire weather data, weather variations for the given location, like say Pune location, considered. And means you can say that can we depend on these values? So yes, we can depend on these values because weather variations is being considered. Just the problem is that 1990s weather. If you there is a huge change in the weather or ambient temperature during 1990 to 2024. So if you go for the higher software or for particular one, you need to get the data for that particular location, and you can check that what is the change in the output also. So one can study out of this one PVsyst, you can study that if I set up the plant in the 1990 and 2024, what is the difference in the output depends based on the weather parameters change. So people are used to say that there is a change in the weather, or what you can say, global variation, that temperature is rising and all. So if this particular parameter puts some effect on your panel productions, that analysis you can do it based on this particular data. But you need to get the updated data only for that one. Again, these are the some numbers. So I'll close this one. These are, if you require the tables, the loss diagram as I shown it already. So what are the loss parameters are there? Now, as a user, I need a report. As a user, I need proper printed report which can give me the idea about the entire solar system, how my plant will behave with the given data, with the given load and all this stuff. So once you click it on the report, it will take some time to generate it. Just wait for that one. Okay. Sorry. Okay. Once you click it on this one, now this is the project. I have given the name, that this is a trial version. You will get that watermark of trial version, and you will get. I'll try to zoom it. Now you will get the entire report. What is the your orientation and what is the latitude, longitude, and detailed data, and you will see that what are the array losses. These are the numbers what we have counted from. We have selected the panel of 545 watt peak. The total panel required is 24. The number of what is it? Power is 13.8. So 13 kilowatt plant is there. Now these are the our lamp, and these are the load we have defined it. So based on that, it is calculated energy, total energy required over the year. And these are the graphs. As I mentioned that we can generate these graphs as ever we want. These are the tables for the results. So tables, loss diagrams, and preferred graphs are there. So this is the entire almost 8 pages report it can generate, which you can go for the analysis. Now here, if you want some different diagrams in the report, you can add. You can, if you want something different analysis you can add from the PVsyst. So these are the report generation from the standalone system. Is any doubt or anything is there? You can ask. Yes, is there any doubt? Okay. Now see, the PVsyst works. See, there are a lot of parameters considered during the simulation of PVsyst. There is a similar software. What is the problem with the PVsyst? It's a paid version. The similar software you can search for open loop, that is called SAM, that is System Advisory Model. That is also another software. You can go for that one. And if you are interested in the programming, there is a library called PVlib, PVLIB. It's a Python library. You can go through that one also. But means I have gone through the softwares. The parameters included in the PVsyst, like say losses and all these terms, are not available precisely in that particular one. Yes, they are available, but the way we can modify the parameters in the PVsyst, it's very difficult to handle those parameters in the open source softwares. Yes, open source it's still under the development, but you can go for that one also. So this is one of the software where we have seen one parameter over here, that the standalone system we have, and we are going for that one. So what is requirement and all. Based on that, we have simulated one data. Tomorrow we will see what is this grid connected system. Meanwhile, if time is there, so we can go for the pumping system also. So I'll close this one now. Yeah, it will ask me to save the data, so I don't want right now. So I can go for that one. So I'll exit this particular one without saving because I can modify it like, if I want it. Okay. Now, PVsyst, as I mentioned, once you install the 8 version, you'll get the three options: grid connected, standalone, and pumping. Okay. Here you can see that the design one. So we'll see the pumping quickly because there is not much parameters are there to design. It's a simple one. The pumping is it is a solar based pumping. uh, you can use it for the well or in the rural areas to pump the water from the well for the farmers. So I'm just going for the similar data. So here I won't spend much time. So I select the Pune data here, the Pune site here, and I need to save that particular one. So I'll use the save. Okay, and here again it will ask the orientations. I won't spend much time here, so I'll keep the orientation as it is. It's really it is good. So the water needs, now here's the change the thing. Now here's the system. You can see on the right hand side, here's the system that we are pumping the water and we are storing it in one of the tank or we are using it, and all this one we required it solar for that one. So deep well to the storage, that is the one of the system, or lake or river to the storage. So based on the system requirements, we are changing it. So again, we are just giving some random numbers here to check that the static level, let's assume at 2 meter, and flow rate we can say it, let's say 1, the pump level and all this stuff. We'll keep it as it is. The pipe choice, I'm not good in the selection of these numbers, but I'm just keeping that numbers, number of elbows, let's say 2, the friction losses, let's assume 0. Okay, and this is the system we are designing for. Volume we required storage tank volume, let's say it's 10 meter cube. The diameter of this one, let's say, I don't know, I'm just keeping the, oh, I need to keep it like that one only. And it is giving me water full height, feeding altitude, let's say in meters. Okay, or button elimination means we can keep it like this way, and we can click it on okay. Okay, you didn't define the water needs annual value. Where is, mm, oh, so here we can define some water needs per day, let's say, defining just some numbers just to check that how this particular one. And it is saying that the length of the pipe between 13 meter. Okay, so we'll keep that one into the mind. Yeah, okay, where is the length of the pipe? It's okay. So understand this one. This is the one of the way to learn also again. Whenever you go something wrong here, so here I have kept the length of the pipe is 2 meter only. Now it is saying that it should be minimum at 13 meter. So whenever you go wrong in this particular one, I'm keeping it again. Okay, so it shows you the error here with the red one, and it is saying that the length of the pipe, at least as long as the level difference between the pump and injection is, should be 13 meters. These are the thumb rules applied by the uh, PVC. So we need to be followed that particular one to avoid this. Now system again, need to design the system here. Requested autonomy and all this stuff already given to that one. Sub array design. Now here I'm going for the no sizing. So I'm selecting the panel as ever I want it, let's say 520 watt. So it is saying it's only one panel is required. Universal controller, I'm going for that one. And pump, here again I'm not selecting good. I'm going for one pump, let's say 700 watt. One pump we required it, and nothing else for that one. So I'm just, okay, control strategy is not defined. So here I'll define the MPPT one. That would be the good one, nothing else. Or we can go for the fixed TC also. Okay. Okay, what is the error? The pump minimum head is over the maximum static pressure need. Okay, so I think I need to be good in this particular selection. Okay, okay, pump the minimum head. So we need to be okay. Here it is. The head. It should be more than the maximum. What is the value? It should be. I'll keep some value here again, 30 or something. Okay, 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 okay. It's from this one particular one that the head value should be more than the maximum static pressure. So I'll select some different pump if it is possible. Not yet. I'll go for the higher values. Okay, now it is accepted that higher value pump, but it is not accepting this particular one. Okay, so I'm just selecting some values. Okay, again it's producing the same error. Need to check. Okay, so pump. What parameter we are missing here? It is good. It is good. I think we should be go back in that particular one pump definition because maximum static pressure needs it's not mentioned anywhere here. Because whatever the value pump we are taking it's still showing me the same error. So okay, we'll see this particular point tomorrow itself because it is not giving me the exact answer and the same error again and again. The minimum head over the maximum static pressure because it's not defining the maximum static pressure anything anywhere. But I'm just going to check that. Let's see the change this one. No, it's still producing this error. I need to check that. I'll check this particular one. This is the additional one. So tomorrow we will see the grid connection and this particular error. I'll look into that. Why it is giving me this error. I'll look into this particular one and we'll come back to you. Okay, so any doubt, any questions you have, please. Okay. So tomorrow we will look into the grid connected systems, how to design that. We will try to add one of the near objects also, and we will see how that particular object. See again, in the trial version they are not giving much of the options open for us. Uh, when I am learning this particular one, so we have options that we can go to the Google map also, and we can select the locations from that one. But this option is not available in this particular one. So in the trial version, they are not giving the exact one that okay how we can link it to the Google map and how we can add this particular location. So that is the issue. So even with the near-term object addition, if we design particular objects and if we set up some objects nearby, so sometimes based on the Google Maps also it's extracting the objects. But most of the times it's in this particular version it's not. So that's the issue I would visit there. So if any questions, queries are there, I'm ready to answer. If nothing is there, we will meet tomorrow to go into the grid connected system. Yeah. Okay. Thank you. Thank you.